Mike here from the Point Studios. Did you know you could turn sound into light? The process is called sonoluminescence. It means sound into light, and it takes place in bubbles. Or bubbles. Just really small bubbles that are made by cavitation. Cavitation is when you violently tear apart a fluid such as water, creating a cavity, or air bubble. Wait, air bubble? Where'd the air come from? We're underwater. Shouldn't that be a vacuum? That is an excellent question. So let's assume we have a vacuum bubble in water. What happens? Well, due to the extremely low pressure, vacuum is kind of zero pressure, evaporated water and dissolved gases will start to fill the bubble, and if we're dealing with aerated water, which we usually are, much of the gas inside the bubble is actually air. Dissolved air fills the bubble while it's underwater. This is kind of crazy, but it's actually true. Now, cavitation bubbles tend to be extremely unstable. A low pressure pocket surrounded by much higher pressures is kind of like sitting between two rather large individuals on an airplane. Bubbles collapse inwardly very quickly, often violently, which can cause some nasty damage to machinery. But under the right conditions, a bubble can collapse so rapidly that the vapor inside heats up to tens of thousands of degrees and lets off a burst of light! And this is where we have sonoluminescence. Large pressure waves, sound, literally tearing apart liquid water and collapsing so violently it gets hot enough to produce light. Sound into light. And as with most scientific phenomena, we stumbled on it quite accidentally. In 1934, at the University of Cologne, Frenzel and Schultes tried to use ultrasound to develop film, and what they found were tiny flashes of light, created by sound. Since then, we've noticed this effect in ultrasound, ship propellers, and even shrimp. By the way, the pistol shrimp and the mantis shrimp can snap so hard it actually creates tiny bubbles. Shrimpoluminescence. But it wasn't until the late 1980s when we figured out how to trap a single bubble and study its properties, which you can actually build one yourself with a little equipment. And it looks awesome! Seth Putterman of UCLA called it a star in a jar, because we have a little blue light flashing thousands of times a second. So it twinkles. Pretty cool. Thanks for watching this episode of Acoustics. If you'd like to see more sound and vibration science videos, please subscribe. I'll try to get out quite a bit more than I have been in the past few months. You can follow me on a couple social networking sites, and I already said thanks for watching, so this is awkward.